Hi, this is Miss Smith here, bringing you another video with Enrichology Tutoring. This time I'm going over rational equations once again, but I'm upping the ante a little bit. We're going to be talking about rational polynomial equations. The difficulty of the polynomials is going to increase here. So when we're looking at equations that are polynomials, you have fractions, or sorry, when we're looking at rational equations, there are polynomials in both the numerator and denominator at the top of the fraction and the bottom of the fraction. And then, there's also fractions sometimes within the fraction. Of course, one of those rules, no zero denominators. Why? Whenever you're dealing with math and you have a fraction, 0 over 1, that's 0. All right. But 1 over 0, that's undefined. And it is a common, saying that if you're looking at a y value, that can exist. I'm sorry, for some y value, there isn't an x value. So when we're dealing with an undefined function, we can't have an undefined function. So no zeros in the denominator. That also creates what's called a domain restriction. Some value of x that cannot be. What number is that, or what value of x is that the domain will equal 0 if I had that there. So this video is also going to be 2 parts because it's such an in-depth or meaty concept. So getting started to it. I use this little acronym, HIDE-Z. So I remember the parts of things that I need to solve for when dealing with rational equations at this level. H for horizontal asymptote. So you'll also get to the concept of limits. A horizontal asymptote deals with that, indeed. It depends upon the coefficients in the leading term, and I'll break that down right here. So your horizontal asymptote has rules. Whenever the exponent on the leading coefficient on the numerator is less than the coefficient, or less than the exponent on the leading coefficient on the denominator, then your horizontal asymptote is y equals 0. So this would be your asymptote line, meaning that you'll have a graph that will go towards 0, but never, ever, ever touch 0, okay? So when we're looking at the next one, when the leading term or the exponent on the leading term on the numerator is equal to the exponent on the leading term in the denominator, your horizontal asymptote is going to be equal to these two leading coefficients in creating not a slope, but the point where y is equal to where you'll place your line. So example, this will be 2/3, which is 0.22 or 0.66. If I drew that out and this is my 0, then I would have a horizontal asymptote. Let's say it's right here, and that is y equals, was it 2 over 3, 0.66, and then my graph will infinitely approach that 0.66 or 0.23 0 or 2/3 right here, but it'll never actually get to this y equals 2/3. Now the last scenario is if I have the exponent on my leading term on my numerator is greater than the one in my denominator. There's no horizontal asymptote. Yay! But there is an oblique one. Yay! So that requires a little bit of extra math, which I'll show you in the example. So then after that, these are the different things you can solve for. Your intervals describing how it behaves as you go through different values of x. Discontinuities, these are places where it starts to break down. So for these values of x, there will be holes. There will be vertical asymptotes, meaning that the line will approach the number but never get there. And there are even what you call jump discontinuities, meaning that y changes. Then we have end behavior. The end behavior is going to be determined by the, not multiplicity, goodness gracious, degree of your leading term right here. This is odd, so it's going to be, the end behavior is going to be that of an odd function, be it like this, something where you have a graph where it has one up, something up, the other down, but it's going to be like that. That's an odd behavior graph. And my end behavior will be based upon that, where one side will be going towards a positive y infinity, the other side will be going towards a negative y infinity. And then zeros. Your zeros are based upon this function, your numerator function. So you solve for the zeros of x right here to get said zeros. All right. So that is an explanation of rational equations, the basics of it. We have hide z, all the different things we solve for with these. And in the next video, I'm gonna do a practice problem.